Hey everyone, I am Bhagilakshmi, Department of Mathematics, SNS College of Technology. Today we are going to discuss about the formation of PDE. So in this already we discussed in the formation of PDE in two ways we can derive that partial differential equation. The first one is elimination of arbitrary constant and the second one is elimination of arbitrary functions. Now we are going to discuss about the elimination of arbitrary functions. So in this, the formation of PDE by eliminating the type 1 is we can discuss now. So the type 1 is nothing but the elimination of one arbitrary function. So for example, form the PDE by eliminating the arbitrary function from z equal to a function of x squared minus y squared. So take this function and note it as equation number 1 and differentiate this function partially with respect to x and y. If we differentiate with respect to x and we get differentiating z with respect to x is nothing but p. In the right side the function, so function for it's look like f of x. So differentiating f of x is f dash of x and then this bracket x. So with respect to x means nothing but x differentiating x square you get 2x. From this you want to eliminate this function only. So keep this in one side and the remaining terms in the right side. So we get f dash of x square minus y square equal to p divided by 2x. And then the same procedure we can proceed for the with respect to y and differentiating this function given function with respect to y. So we get the function in the left hand side with respect to y is q and in the right side f of x. Differentiating f of x is f dash of x and then in this bracket minus y square alone will come, that is minus 2y will come. So as we want to eliminate this function, so keep this in one side and the remaining in the right side. So after this comparing the function equation number 2 and 3 and we comparing these two and we get the left hand sides are equal, the right sides are equal. So comparing these two and we can write these two as a inequality condition. So after this cross multiply these two and all together comes in the numerator. So p in this 2 we can cancel and py equal to qx alone will come. So I'm taking writing in one side px plus qy equal to 0 is the required partial differential equation. So this way we got the equation. We can see one more example based on this sum in this model. So the first next one is given equation is z equal to the function of xy divided by x. So differentiating with respect to xy, that nothing it is in the left hand side automatically that function is with respect to x is p. Next always the function f of x differentiating that function is f dash of x and then this x is in the form of u by v. So what I am doing, we are applying the formula u by v formula, that is z square. Immediately write this z into differentiating the numerator with respect to x, get we are writing the constant, differentiating x is 1 minus writing the numerator and differentiating the denominator. So this way we got the first value. After this here we want to remove only these terms, so keep it in one side, another take this function to the denominator. Okay, so having write like this and then at last same differentiating this given function with respect to y and we can note it as y and in the right side again we will get like differentiating f of x is f dash of x and in the right side this xy divided by z we can use the u by v method. So again we get with here only the changes differentiating with respect to this xy, x is a constant and y is a function, like that we want to differentiate this. Here alone we get the difference. Okay, so in the next line q equal to this f dash into this term. So this function is take it to the denominator and keep this f dash alone. This f dash and this f dash these two, if the left hand sides are equal, that is this f dash value, this f dash value, the remaining and all we take it to the left hand side. Comparing these two, right sides are equal, then left hand sides are equal, then we can compare these p and q values as is shown. So what we did in the last sum, the same procedure I am doing here also. The same thing, the cross multiplying these two concepts, and left in the take it remaining, take it to the numerator. The terms we can, what are the terms we can cancel, we can cancel here, and multiplying all together and take it to the left hand. This plus or minus, these two terms are cancelled, remaining we got only this, and here also this z and z we can cancel, px equal to qy alone we got. So this is a required partial differential equation. So this way we can calculate the term. Thank you.